All right, so in example 2, again, we're given a graph of f and a graph of g, so we're not limited anymore to just like x equals 3. And we can pull our own values out off like we did on Graphus Interruptus. But because these aren't continuous, if we run into a DNE, then we have to break it down into the limit from the left and right. Okay, so keep that in mind. So let's look at example 2a together. Limit as x goes to 0 of twice f plus 3g. Same thing is to rewrite the limit and put it directly in front of those functions. So here we go. This is going to be twice the limit as x goes to 0 of f of x, bracket squared, and again, brackets here, just extra parentheses, plus 3, the limit as x goes to 0 of g of x. All right. Now, we can't just like take the values that are given to us. We got to go get them ourselves. So these are general limits. So we go to f, which is on the left, and the limit from the left is 2, right? And the limit from the right is 2. You'll see that? So that exists. We can replace that with 2. Bracket 2 out front, 2 squared. Roger, check. 3 times. All right, on g, we're approaching 0. And from the left, it's 0, and from the right, it's 0. So that one is definitively 0. And again, free response. We're Brooks and Dunn there. And now we'll keep going for multiple choice. 2 squared is 4. 4 times 2 is 8. 8 plus 0 is 8. Okay. Nicht so schlecht, not so bad. Kind of fun, right? Comments, questions? Quips, quote, concerns? All right, do your math homework, right? Vote right? Good. Number B, the limit as x goes to -3. So again, we've got 3 different places there. So we got the limit as x goes to -3. You could do this as x squared, or you can do it the limit of x and then square the result. It's up to you. We know that x squared is continuous everywhere, so I'll just leave it like that. And then the limit as x goes to -3 of g. This is a little bit tedious, right? Writing the limits every time, but at least it's fun. All right. Now, for the first one, of course, x squared, we'll evaluate that by direct substitution. And just be a little bit cautious if you plug in like this, -3 squared. The way I have it plugged in, is that correct? Take a look at it. No, that wasn't me being haphazardly careless. That was deliberately wrong, right? That's going to give you a -9, right? That's 3 squared times -1. So just be careful. -3 quantity squared, or you can just call it +9. Now we're going to g of x at -3. So here's -3. I drew these myself, just kind of assume that I want that to be a horizontal line segment, right? So that's 1. That works. And then on f at -3, this -3 here. So from the left and from the right, they're approaching the same thing. That's -1. So again, you can assume that that's a slanted line. And there is your free response answer. And of course, the multiple choice answer would be -9, right? Good. The -1 on the bottom makes it negative again. By the way, I don't know if it's come up so far, but if we're working straight down, and I almost ran out of room there, don't like draw an arrow like that. That's just kind of tacky. Just draw a vertical line and then continue straight down in the next column from left to right. Okay? Yeah. All right. So far, so good. Hello. Hi. Good morning. Welcome. Merry Christmas to you too. We'll be there before you know it. All right. Can you pass this forward? It's for Mason. All right. Number C. All right. So now, here we go. For the first time, this is the limit as x goes to -3 of what? Is that g times f? No, that's g of f. All right. So I'm going to bring it inside. I'm going to call this g of the limit as x goes to -3 of f. Like that. And now I'll evaluate the inside. So -3 f, that's the one on the left. We've already done that one. We're approaching -1. Okay, so that exists. Now here's where you have to be real careful just with your notation. Don't just replace it with what it's equal to, right? We're used to physically doing that in location, not just in value, right? G of that, well, if that's equal to this, then now it's G of this. No, because the right-hand side is now in a function context, not a limit context, right? You don't have to put does not equal G of -1. I just did that to warn you, okay? Rather, instead, we're going to take the limit as x approaches -1. Now, from which side? It started as a general limit, right? See that? This is where it can change from a general limit to a one-sided limit, or it can stay a two-sided limit. How do we know? Well, let's come back over here to -3. Here's -1, right? From the left side, it's approaching -1 from below -1, right? Which is from the negative side. As we approach horizontally from the right-hand side, it's approaching -1 from vertically above -1, which is from the positive side. So that's a two-sided limit, okay? The y values are coming from below and above. So now when we do our next iteration and the output becomes the input, we still have to approach from the negative and positive side. Does that make sense? So it's really just with composition that we got to be extra careful. So I can keep it as the general limit. And now it's going to be of G of X. All right. Now we'll look at G of X at -1. From the left-hand side, it's approaching +1. And from the right-hand side, it's also approaching +1. Does that limit exist? Yes, right? And it's going to be +1. Does the function value exist there? It does, right? But it's not continuous there because the function value is 2 and the limit value is 1. So just to complete this, G of -1 is 2, but the limit as x goes to -1 is 1. So there you go. If this were a multiple choice question, notation's not graded, it's so important you don't make a careless mistake and change a limit question into a function value question because you can get the wrong answer. Okay? All right. So composition. We'll just say here, like Dora used to tell us, cuidado, cuidado. Just be extra careful when you're doing it because, well, two reasons, right? You don't want limits to turn into function values. And on that second iteration, a two-sided limit may become a one-sided limit. All right, let's look at this one. Part D, the limit as x goes to -1. This is also composition, right? But instead of two unknown functions like f and g, the inside function is x squared, our old friend x squared. So step one is the same, bring it inside. So now it's g of the limit as x goes to -1 of x squared. We can evaluate this one by direct substitution, right? And we get 1. -1 quantity squared is 1. But this is where, and it's a little bit different, and I've overlooked this in the past. When you square it, you get +1. 1 becomes now our new input. We're approaching +1 now on g of x. Is it still a two-sided limit, or does it become a one-sided limit? Well, let's look. Here's the graph of x squared, right? X squared comes in like this. As I approach -1 from the, I'm sorry. Yeah, here's -1. As I approach -1 from the left-hand side, it's approaching 1 from above, right? Which is the positive side. And as I approach -1 from the right-hand side, it's approaching from below 1, right? Which is considered the negative side. So because I am approaching from two sides, it does stay a two-sided limit, okay? So again, it seems a little strange at first, but we're approaching horizontally from the left and right. And we got to see what the y values are not only approaching, but how they're approaching it, from above or below. If they're approaching from above and below, then that output of y values becomes a new input, left and right of. If they happen to be approaching both from above, it becomes a one-side limit. So for instance here, if I approach 0, if I approach x equals 0 on the graph of x squared, from the left side, it's approaching 0 from above, right? And from the right side, it's approaching 0 from above. So on the next iteration, it's going to become a one-sided limit from the right side only, the positive side, okay? When you're talking about horizontal, positive is to the right of, negative is to the left of. When you're talking about vertical, positive is above, negative is below. Eek. We'll get a chance to practice that. I did add some questions, Landon, to the worksheet that deal with this exclusively. So anyway, now it's a general limit at 1 for G. Not that it matters, because here's 1, the limit from the left is equal to the limit from the right, which is what? -1. Right? All right. Party indeed, right? Under the cheetah snuggie. Let's go ahead and plug in. 2 times the limit as x goes to 1 from the left of f of x, all over bracket the limit as x goes to 1 from the left of g of x, quantity squared. 89%, I think I can walk around. All right, so carrying it down, we got the limit from the left of 1 on f. Left, that's a lot to keep track of, right? Left of +1 on the left graph. Here's +1. Approaching from the left is 1, right? Oh, 2. Whew. I was stuck in a 1 there, right? There we go. Approaching from the left, we're approaching the open circle at 2. So I can do this, boom. And in the bottom, I'm approaching 1 from the left on G. So there's G. Here's 1. From the left, I'm approaching -1. So not necessarily difficult, but a little bit tedious. You got to be kind of meticulous and detail-oriented. Free response, there we go. We're done. Multiple choice, we go with 4. Okay. And last and certainly least in this case, F. We only have 2 variables. So let's go ahead and write it as 5 minus the square root of, the limit as x goes to -1 from the right, of x squared times 3 plus the limit as x goes to -1 from the right. It's not even last. I see G sticking out over there. All right, so bringing down the 5 minus. Limit from the right-hand side of -1. Well, again, you can use direct substitution. -1 squared is +1. So this becomes 1 times, and then 3 plus, approaching -1 from the right on the graph of F. -1 from the right is 2. Okay. Free response, that's it. And then simplifying, we get 5 minus the square root of 5, and that's the answer. All right, now on part G, I'm going to let you do this one on your own. Or any questions so far? By direct substitution. Yeah, because we don't have the graph of x squared. If it's not in terms of F or it's not in terms of G, we can use direct substitution. Right. I know we're putting all the pieces together here pretty quickly. The square root out. I just brought the limit inside the square root. Yeah. Yes, you could do that because it's like an exponent, right? It's like to the 1/2 power, which is essentially rule number 5. Okay. Yeah. Anywhere you have a variable or a function, you can reproduce the limit notation, stick it in there. Now, I do want to give you a chance to chew on G by yourself. Okay. Not that there's anything exceptional about G, but there is kind of a little twist to it. So go. That's multiplication on G. You're doing composition. Yeah. Yeah. Yeah, the dot. And you wouldn't have 2 of x's. It would be f parentheses g of x close parentheses. Open circle, right? Yeah. G is multiplication. Multiplication, not composition.
It does not exist. You can't multiply. You can. It doesn't. 1.3. I don't know. That's okay. 1.3.
On the recording. All right, first of all, just a real quick distinction between multiplication and composition. F of x dot g of x is multiplication. There is the abbreviated composition, which I don't like to use that much, but the open circle that's in the middle there is composition. It's like the O from the word of, right? So if you see fog of x, 1 of x, that's composition. It means the same as f of g of x. So this is multiplication. Now, it is a general limit. So let's go ahead and try the general limit of f times the general limit of g. And I'm going to avoid rewriting it, but here we go. At 2, right? What do you notice right away at 2? The limit from the left and the limit from the right of f are different. So the general limit of f is dne, okay? The limit as x goes to 2 of f of x by itself is dne. Now, you might think that dne times anything is dne, right? But that's not necessarily the case, all right? Because the 2 one-sided limits exist, and this is built up of more than one thing, this is where you have to do both sides. So we need to look at the limit as x goes to 2 from the left of f times g, and you can write it like that. And then we need to look at the limit as x goes to 2 from the right of f times g. That takes us back to the definition of the general limit, which is this right here, okay? So let me find where I'm at. There we go. So over here, the limit from the left of 2 is 1, and then left of 2 is 0, okay? So this ends up being 1 times 0, which of course is 0. And then the other one from the right of 2, The right of 2 is going to be -1 times 0, -1.
That's the bell. Wait.
Yeah, that is 5 minutes early. Does 0 equal 0 real quickly? Yes. Okay. So,
Students, please pardon this interruption. That was an operator error. I apologize for the early bell. The announcement I was wanting to make is 5th period ROTC students, you will meet at the auditorium. 5th period ROTC, you will meet at the auditorium. We still have about
There you
5
go.
minutes for this lunch.
there you go. Okay. So because there's not an equation and we're looking at combination, not necessarily composition, but in this case, just combining it by multiplying. If you hit a DNE snag, you got to break it up into 2 separate sides. Okay. So you can't just say that DNE times anything is DNE. All right. So yeah, some of y'all are getting 0. That's great. All right. Fantastic. So might want to put a star by that. All right. Now example 3. These are the new ones this year. Landon hadn't even seen these. Let's explore some limits for which we must carefully heed the warning in the note above, right? The red one. This one is off an actual AP exam. This was the BC 2016 International Edition, right? International Edition. I'm just going to let you try it. You know, try this one. We'll go over it, this one and the next one next time together. So deliberately, we did not finish today. So remember, 1.1 worksheet is due tomorrow by 9 a.m. We'll finish this set of notes tomorrow, and we'll roll right into the next section. It's not open? Okay, crap.
I noticed that.